Good morning, everyone. I'm Farzana and I'll be an instructor for the course VLSI Design, which is CSC 460. Okay, so VLSI Design is a very interesting course, and it is basically about the chip design process. And you will read numerous topics on this course and about how can we get a proper functional chip from a semiconductor industry. But today I'm going to discuss about the topic reliability and testing of VLSI circuits. So I recommend you to read this chapter 16 from the book Introduction to VLSI Circuits and Systems, a book by John Pimura for the further details and instructions. Okay. So now, as I said, we are talking about testing and reliability. So you can see there are four key topics which I marked in this slide are testing, reliability, problems or random variations, and sets of electrical tests. So I hope at the end of the lecture, you can get a clear concept about this topic. Okay. So first of all, we are concerned about the wafer testing. So we need to know what is a wafer. Okay, so a wafer is a thin slice of semiconductor material such as silicon used for the fabrication of IC. The wafer has been prepared after a series of complicated steps, but at the end of the manufacturing process, the wafer should be tested properly. A test probe head connects to the computer through the probe arm, okay, and we apply different kinds of input stimuli such as current, voltage, temperature, pressure in the input, and then we take the output from the response and then compare to the standard one to check whether the wafer is properly synthesized or prepared or not. Okay. Then comes the dicing and packaging. If a wafer is successfully passes all the tests, then it is cut along lines then that run in between the individual die sites. This process is called wafer dicing. Okay, I you can see the definition in this slide. Okay, then comes the packaging process. The circuits which are good circuits, they enter in the final assembly phase where it is packaged, and you can see the purpose of chip packaging in VLSI are protects the delicate integrated chips. Okay, the protect electrical connections between the IC and the external circuit board and allows for efficient heat dissipation. Okay, you can see there is a metal cover which we use in the packaging step, and it helps the chip to dissipate it extra amount of heat, and which also helps to prevent the chip from extra heat dissipation. Okay, and then it facilitates handling and assembly during manufacturing and testing. Then comes the question reliability. Reliability is very crucial in VLSI circuits, and it is basically dependent on the lifetime performance and overall cost of electronic devices. So you can see there are some factors which affecting reliability. The first one is the manufacturing defects. The second one is material properties, and then design and architecture, operational stresses, packaging and interconnects. So there are a short information I provided in this slide, but I recommend you to learn to read the this chapter from the book for a vivid description. Okay? Then the reliability bathtub curve. The term we can easily visualize reliability from this curve. You can see there are three segments in this curve. The first one is the infant mortalities, the second one is the random failures, and the third one is the wear out. Okay, so what are the steps? And I gave a very short description. Okay, so in the infant mortalities, it is the situation or it is the phase includes that failures due to manufacturing or handling of a chip. Okay. Then the random failures. If a chip is failed during its projected lifetime, then it is called the random failures. And the final one is the wear out. The wear out indicates the end of the life. Okay. And if the chip is burn out or it destroy or it is malfunction during the wear out process, then it is desirable. Okay, then the term comes CMOS testing. We can easily the CMOS is the key component of the VLSI chip, so this should be properly tested and checked. We need to be very careful about the possible faults such as short. You can see there are some kinds of faults such as short circuit fault, such as open circuit fault, and there may be some kind of bad transistor. So these false should be tested properly, and then the logic should be verified properly. And so what are the logics? Okay, the logics are basically the logics of digital electronic circuit, such as NAND, NOR, NOT. Okay, so in this you can get a vivid description from the logic in the digital electronics course or digital logic course. Okay, and then you can see some important points are pre-silicon testing, manufacturing tests, and test pattern and vector generation. We generate a test pattern or vector for the testing process of CMOS. Okay, and then the reliability testing. Okay, so class, that's all for today. And if you have any question regarding today's lecture, you can ask me.